Okay, so the topic is finding geographic data. We're talking about all of the geographic information that we use in geographic information systems. We refer to that information as geographic data. You'll also hear us refer to it as spatial data. Today we're going to look at different places to find GIS data. Another term you'll hear, GIS data, geographic data, spatial data. All these terms we'll use interchangeably. These are the layers of geographic information that we build, manage, analyze, edit, that we use in our geographic information system. We'll look at some places to find geographic data, some different ways of finding it, and we'll also explore these GIS data formats. It's a pretty important topic for an introductory class, and really in any GIS class that you'll take. So when you think about acquiring data, there's some steps that you go through for any GIS project, and acquiring data is one of the first things. All right, so you got to get some data before you do anything else. So here are some common things to ask and to think about. What data do you need? Are you mapping floodplains, or are you mapping trails? What are you mapping? What kind of data do you need? Are you looking at some kind of something they're doing in the state right now is remapping voting districts and precincts. For that, they look at race and population and things like that. So census information. What kind of data do you need? What's the purpose of the data? So that's very similar. Another project I'm looking at doing right now is looking at the slope of trails in the national forest. They're looking at trying to better maintain trails, and the steeper slopes are the ones that they need to focus on first. So the purpose of the data of that would be the location of the trails, and we also need slope data to determine the trails that are maybe on slope that's too steep. So another question people kind of forget about, thinking about whether or not you actually already have the data. I've got terabytes and terabytes of data. I've been doing GIS for over 20 years. I've done hundreds of GIS projects. Sometimes I forget that I've even gotten data from somewhere else and already have that data. If you've forgotten that you have the data, it might be out of date at that point though. So that's a consideration. Thinking if your data needs to be updated. If you already have data, maybe you have to update it. So if you do already have data, you can search internal sources for data. Within ARC Catalog and ArcGIS, there are some ways for searching for geographic data specifically. So we can use tools in the software to search for data. We can also search external data sources, and we're going to see some examples of external data sources today. Also, whether or not the data meets your project's needs. Oftentimes we have to modify and update the data to help it fit into the project that we're doing. Maybe add an attribute and populate it, or add actual geographic features to it too. If you answer yes to all of this stuff, you can use the data. If you can't find the data, it doesn't meet your project needs, you don't already have the data, you have to keep looking for it, or you have to create it yourself. So we covered most of this, but I'm going to talk a little bit about some of these as we go through it. Your data purpose, it'll fall into a couple of broad categories. Right? Either the data you're looking for is directly involved in the analysis of the project. For instance, that trails work that we're looking to do, I need trails data, and I need some slope data to determine the slope of each trail and even each segment of trail. Those layers are the analysis layers that I'll be working with. But in every map, you have a bunch of base information or reference information. So other information for that map will include things like trailheads, maybe streams and rivers, any kind of hydrographic features, maybe bridges, other things like the ranger station and other points of interest. So in every map, you've got data that's being used as base information. In a lot of maps, you also have some analysis you're trying to perform on specific layers. As I mentioned, ArcGIS has a search tool as far as whether you have the data internally or not, and you can search based on name, keyword, geographic area, things like that. You can also just search your File Explorer for data, which I do a lot of. External data sources, we're going to see some of these. I'm actually going to demo all of these. So if the data is external, you need to think about the geographic area you're mapping. If you're mapping a small area like a neighborhood, or maybe just the part of a town, you want to start looking at things like the city for the data sources. If you're mapping a small area within a city, the city probably has, if they have a GIS department, they probably have better data for a small area in a city than the federal government's going to have. So you think about how big of an area you're mapping and what kind of information you're mapping. If you want to map parcels, if you need parcels on a map, counties manage tax parcels. So property lines, that would be at the county level. If you're looking at mapping things like national forest, you may need a combination of all these things. If there's cities close to the national forest, but the national forests are managed by the federal government. So it's a bigger, broader area mapped at a smaller scale, which is a larger area. So you kind of got to think about where you're mapping and what you're mapping, and then you start looking around in external sources for those things. Here are just a few data sources, local and other. Since we're here in Asheville, I like to mention some of these Asheville and Buncombe County related ones. Open Data Asheville, the second one down is the City of Asheville's Open Data Initiative, and you'll see that if you go through the program, the GIS certificate here, and we'll get a little demo of it today as well. Buncombe County has a GIS site as well. Statewide, if you're looking for data across the whole state rather than just within an individual municipality, NC1 Map is a great statewide, it's our statewide GIS data clearinghouse. We're pretty lucky in North Carolina to have such a good statewide GIS organization. It's called the Center for Geographic Information and Analysis. It's in Raleigh. They have an employee here and some across the state. Some states don't have GIS managed as well at the state level as North Carolina does. So we can get a lot of statewide data from there. And then some federal data sources. The Forest Service has a geodata clearinghouse. The USGS has a similar geospatial portal that you can download data. There are hundreds of others. Locally here, the Metropolitan Sewer District has a lot of GIS data, and I haven't looked really recently, but you used to be able to stream data from their GIS servers directly into ArcMap, so you could consume their data through the internet. You couldn't download files like we'll see today, but you could access their data. And then nationwide, the federal government, they use GIS to do a lot of things, and they make that data available. The NOAA and the what used to be the climate group here in NOAA, y'all remember them? They used to, it's not NEMAC, I'll come back to that. They're right in the federal building downtown. They changed their name recently. So there's lots of federal groups that have GIS data, and we'll see some of them. All right, so all this data exists in some kind of computer data format. All right, so what is a data format? A data format is a method for the computer to store and then display data back to you. We all work with data formats all the time. All right, a Word document, a .docx. The .doc is the old Word document. It's a data format. All right, it's a way for Microsoft Word to encode information and store it in the computer and then display it back to you. Software and software functionality and data formats are built together. All right, so Microsoft Word allows you to insert images into a Word document and do fancy formatting and all kinds of stuff, right? And so those tools inside of Microsoft Word work with their data format. So we are making and saving data formats at the computer all the time. When you work at the computer, that is your personal data. It is stored in data formats. So all data formats have advantages and disadvantages, similarities and differences, and I like to talk about data formats that people are really familiar with to start this topic before we moved into the spatial data formats to kind of give you a basis of what we're talking about. So everyone's probably used a text document as well as a Word document. All right, these are common data formats, and they've got a lot of similarities. You can type a letter in either one of these. All right, they've got differences too. Text documents don't allow you to insert images, do fancy formatting, things like that. So is one better than the other? Not necessarily. A lot of people think, oh, well, a Word document's better because you can do more with it. Not necessarily. It depends on what you want to do. Right? A lot of times I don't use Microsoft Word if I'm doing something really simple. Microsoft Word takes a lot of computer resources just to open that program. Right? So if you're doing a lot with your GIS and you don't want to clog up your memory and your RAM in your computer, you don't want the processor to be clogged down with trying to display Microsoft Word, a text document's a better option. If I'm making a grocery list, I'd rather just do it in a text document with a lightweight text editor than using a Word program. So one's not better than the other. It depends on what you want to do with it. In the GIS world, you'll come across text files that are just full of coordinates. And they can be a comma delimited text file. And if it's just coordinates, like the locations of all the cell phone towers in the country, we could download from the FCC, the Federal Communications Commission, you can download a text document of all the cell phone towers. So just another federal organization that has data available. Now that data, is that GIS data a text file with coordinates in it? Not really. It's not really GIS data. It's not able to be read and displayed as points on a map. We can use that file to make GIS data though. So we'll see these kind of things happen. All right. So how about spatial data formats? Spatial data formats are just a method to store and display information too, but that information is spatial information. This geographic data, it's that GIS data. So spatial data formats have developed and evolved over time, and they have changed as computer technologies changed. Just like Word documents have changed. Word documents used to be a .doc file, right? Y'all remember the Word document, .doc? Their format is docx now. Why is that? They changed because computers and technology changed. The docx is an XML-based format. XML didn't even exist when they first started making Microsoft Word. So as computers evolved and the way we process information and store information, as things have changed, data formats change. So you'll see a lot of different GIS data formats. They've been around for a long time, so a lot of times you'll see older data formats, and a lot of times we migrate those into a newer data format. So just as a Word document is a specific data format for Microsoft Word, in the GIS world, GIS software vendors have built data formats that work specifically with their software. They're proprietary data formats. And that was the business model of software manufacturers for a long time. You'd make your software in your data format where only your software could read your data format. And so if someone started a Word document in Microsoft Word, they couldn't use it in anything else. They had to use your software. And they sold software. So it was a smart business move to do that. When I was in school, I'd go to the labs and I would sit down to write a paper, and I had to choose if I was going to open Microsoft Word or Word Perfect. And if I started in Word Perfect, I couldn't work on that document in Microsoft Word. You were stuck using that software. Okay? And so over time, these data formats are easier to read across different computer platforms. Like a Word document, now you can read in the free Open Office program. So you've got a little bit of more flexibility across systems and across software. having complete openness of your data is an open data format. If an open data format, in contrast to a proprietary format, an open data format, the software vendor makes the specifications of how that data is encoded into the format. They make it freely and openly available. So someone else could look at the specifications and build a piece of software that reads and writes those data formats. So I say this because this PowerPoint and our program here at AB Tech, we do a lot of Esri-based data formats because we work in ArcGIS, and these Esri data formats work really well in ArcGIS. We're going to look at a lot of open data formats as well. There's advantages and disadvantages to doing everything. And if you're working inside of ArcGIS, some of the Esri-centric data formats just work really well in the ArcGIS world. If you're working in some other software, you might consider using other ones. And we'll see some of these as we keep moving. So these are the data formats and how they're recognized in Arc Catalog. So all of these are Esri-centric data formats. All right? The geodatabase is the data format that they came out with when they came out with ArcGIS. There was a couple of versions of the software before ArcGIS. There was one called ArcView that was their first Windows-based format. And before that, it was ArcInfo. That was all command line driven stuff on Unix workstations. So when they came out with ArcGIS, which is what we use still, they came out with the geodatabase data format. It's a central repository for all of your GIS data, and its basic building blocks are feature classes. Feature classes reside inside of a geodatabase, and they're essentially your layers of information. They're your GIS data. They're those. We talked in the first PowerPoint about how everything's, we refer to it as a layer. We overlay things in a GIS. The format before the geodatabase was the shapefile. The shapefile was a really popular format for a long time. It's a simpler data format, and it has become the de facto data transfer standard. If you Google almost any county in North Carolina, if you Google Cabarrus County GIS, and you go to their GIS site, I bet you they've got their data available as shapefiles. Okay, you'll find shapefiles everywhere. A lot of times I download a shapefile and I import it into a geodatabase, because in a geodatabase it's a newer data format and you can do more with it. You'll hear me say that a lot. What does that mean? Do what with it? What more with it? It is a more powerful data format that you can do more with it, and we'll see some of the things you can do as we move through this class and other classes. Mosaic data sets and raster data sets are methods of storing raster data inside of a geodatabase. A lot of data formats are either vector or raster. You'll see this distinction between these two data models. We talked about these data models in the first class. Vector data is point size and polygons. They have attributes tied to them. Raster data is a gridded cell structure. Most data formats are one or the other. The geodatabase allows you to put vector and raster data inside of the geodatabase. In ArcGIS, we can view Excel files directly. Excel files often have coordinates in them that we can generate the points on a map from. You'll see that in this class twice, I think, at least. We also have layer packages and map packages in the Esri world. Layer packages and map packages allow you to combine all your GIS data, your symbology, your map, all that stuff into one package to give to someone else, to share. Right, so map packages and layer packages are how we share GIS data in the Esri world. All right, so the geodatabase, it is the ArcGIS native data format. If you're spending all your time in ArcGIS, I'd recommend using the geodatabase. If you're just building some data and you're going to immediately give it to someone to view in AutoCAD or QGIS, you're not doing a lot to it, I might just work with a shapefile, because if I'm giving it to someone to look at who wants to use it in a program, those programs don't read geodatabases as easily. QGIS, you can load some drivers to read geodatabases. CAD, I don't know if you can read geodatabases in. You used not to be able to. So the feature classes are the building blocks of a geodatabase. You can organize your feature classes into a feature data set. This is an example of a map I worked on of the Foothills Trail in upstate South Carolina, and it's got a bunch of data organized in feature data sets based on where I got the data. You can see I've got some data from the census called TIGER. That's a topologically integrated geographic encoding and referencing system is what TIGER stands for. It's census data. Whoops. I've got some stuff from in South Carolina, the United States Forest Service. OpenStreetMap is OSM. PMC is my stuff that I built out from other sources. National Hydrology Dataset, Foothills Trail Conservancy. So all of these feature classes are organized into feature data sets to help me better manage them. Your feature classes store points, lines, and polygons, and those points, lines, and polygons are stored in your GIS with a related table of attributes. Those attributes describe the points, lines, and polygons. So we saw this in a demo last week. Remember, there's a one-to-one relationship between your GIS data, the feature class in this case, or your shapefile, or whatever kind of geographic information you're storing. When you see FTC trailheads there and you see 2 of 16, see the 16 there? That tells you there's 16 records right here in this table, and there are 16 points on that map. So there's a one-to-one relationship between the number of features, or points in this case, and the attributes that describe them. A shapefile has an icon that's similar to a feature class, except for it's green instead of gray. And this is when you're looking at these things within ArcGIS. When you're working with GIS data, these data formats, your operating system is not going to recognize and understand them. What do I mean, recognize and understand? You know how when you look at a Word document in your File Explorer, your operating system has a File Explorer. You probably spend a lot of time using this to manage your files. That's a tool we all use when we work with the computer. And your File Explorer recognizes things like Word documents. See the little icon beside it? Because of that file extension, your operating system sees the file extension there, and it references a piece of software. It associates it with Microsoft Word so that if you double click it, it'll open. Same with PDF files. Your operating system recognizes a lot of files. It doesn't recognize GIS files, and we'll see that soon. Okay? So when you're working with GIS data, use ArcCatalog to manage the GIS data. Shapefiles are an older format, but they are very common. They're a little bit simpler. They don't do things like automatically update the length of a line in the database. You have to manually tell it to show you the length of a line or the area of a polygon. Geodatabases automatically do those kind of things. So we'll look at some of these. So I mentioned this. I got a little ahead of the slides. That's okay. If you're working in ArcGIS, the geodatabase is a powerful format. If you're working in other software, you might be working with other data formats, possibly the shapefile. These are, again, pretty Esri-centric. The shapefile's read across many platforms. The geodatabase isn't. But then how about other software? How about things like Google Earth? Google Earth has its own format too. It's a KML file. So in Google Earth, you can't natively look at a geodatabase feature class. Google Earth works with KML files. So there are tools to convert between all of these things. You can convert from one to the other pretty easily. All right, how about raster data? Raster data It's commonly used to store things like satellite imagery, aerial photography, scanned maps, and things like digital elevation models, surface information. We often store them as TIFFs or JPEGs. JPEGs we're all familiar with. So that's a data format that's not really a GIS data format, but it's been adopted in the GIS field to store raster information. TIFFs are also not necessarily a GIS format, but have been adopted to store GIS information. Mr. SID, you may not have heard of. That is actually more of a GIS raster data format. A company developed this data specification, this data format, just to store GIS data, because GIS raster data are really big files. It covers big areas. They turn into really big files. So a Mr. SID file is a highly compressed raster data format, really used for GIS data primarily. There's also these data formats inside of a geodatabase, like the Mosaic dataset that you'll see in the Esri training. Note that using Mosaic datasets is an advanced functionality in ArcGIS. Your student version is an advanced version. You have the ability to do anything the software will do. But if you end up working in a place that has a basic version, you wouldn't be able to do something like a Mosaic dataset. And there's many other options, like just storing your data as a TIFF or a JPEG. One thing I'll mention about raster data, that JPEG, that TIFF, that Mr. SID, I say that it's like the other JPEGs you see, like the one on your phone. It's the same format, but there's additional information with that allow the JPEG to store coordinates. So it's different in that it is tied to the ground using coordinates, just like any other GIS data. A lot of times you'll see that the coordinate information stored as a separate file in the same folder as your JPEG or TIFF. It's called a world file. And that world file stores coordinate information to tell that JPEG, the aerial photograph, where to display in the world so that it will overlay with other data. With a JPEG, it's a JPW file. With a TIFF, it's a TFW file. And it's got the same name, like Asheville.TIFF would have an Asheville.TFW. And if the software sees a file with the same name with that separate extension, it looks at that file and it uses it to display it in the proper location. We could look at that with some of the Buncombe County data too. Sometimes you won't see that file. The coordinates can be embedded inside of the JPEG, but it's got to be a certain level JPEG and different things. Usually you see a separate file. You'll also see standalone tables like Excel files, text files, CSV files. I use the example of all the cell phone locations in the country we could download from the FCC. They don't have it available as a shapefile or a geodatabase feature class or a KML file for Google Earth. They have it available just as a text file. It's stored in some database somewhere, and they dump it to a text file that you can download, and you can generate points from that kind of thing. So you'll see us. We will use files like these to generate GIS data. It's got spatial information in the file. It has coordinates, but it's not been converted to an actual GIS data format. I like to mention zip files because we get a lot of data in zip file format. Zip files are simply a way people used to use it to try to compress files a lot, and you still do. A lot of times zip files won't compress a file very much because the file format is already pretty compressed, like a JPEG. If you try to zip a JPEG up, it's not going to be much smaller, if at all, because a JPEG is already a compressed format. What we use zip files for even more is combining a bunch of files. If you needed to send somebody 10 files, you could zip those 10 files into one file and then just send one file, and then they unzip it. In Arc Catalog, zip files are not displayed by default. So let's just crank up Arc Catalog and look around for a minute here. Now, within ArcMap, there is the catalog. and this is the catalog window within ArcMap. The catalog window allows you to browse your data. Okay, so I can browse to this Asheville folder, and I can see some shape files here. See these green icons? These green icons show a polygon. This shows points. These are shape files. You'll see in this folder there's also zip files shown. So the catalog window only shows by default GIS data formats. So your catalog window, think of it as the same thing as your file explorer that comes with your operating system, what we used to call Windows Explorer, your file explorer. This is your file management tool. This is your file management tool when you're not working with GIS data. If you're working with GIS data, you should use the catalog, also referred to as Arc Catalog, for your file management. This is your GIS data file management tool. Okay? If you look here in this folder, this is our GIS data folder. If I go to this folder over here, if I can find it, let's go to the S drive, GIS courses, GIS data. See that folder right there? It's the same as this folder right here. If I drill down into that Asheville folder, let's look at the differences here. Notice that, see this Asheville.gdb there? Okay. Asheville.gdb. See how it's got a nice gray icon and it's got a plus sign beside it, and if you click it, you see the contents of this geodatabase. That geodatabase is actually this folder right here, looking at it in your file explorer. If I double click that folder, there's a bunch of binary files in there that you can't do anything with outside of the GIS software. So the moral of the story here, the lesson to take away, is that you should not try to manage your GIS data with your operating system file explorer, or you could mess it up and never use your GIS data again. So to copy this geodatabase, I could right click it and copy the whole GDB folder and copy it to another location. That would work, but it's too likely that you'll end up inside of here messing around and mess something up. So just use Arc Catalog over here to copy and paste this. Alright. An even better example is the shapefiles, the shapefiles. So if you look at a shapefile here, this shapefile is my aerial grid. Now, the catalog window works really good inside of ArcMap, because you can just drag layers over here and view them. Okay? And it's a good tool to manage your GIS data. Outside of ArcMap, you can also open Arc Catalog, and I'm going to do that. I like showing students this standalone Arc Catalog, because it lets you do things. One thing in particular that I like a lot. Here's my GIS data folder. The standalone Arc Catalog allows you to very easily preview things like the Buncombe County buildings. I can preview them right here and actually see the buildings. Okay, I can preview that layer in here, and I can preview the table really easily. Okay, so I like the standalone Arc Catalog window for that reason. Where you run into problems is having ArcMap and Arc Catalog open as two separate programs will sometimes lock each other out. You'll try and do something, and it'll say that file's in use by another program. So that can be a pain. But when I'm first downloading a bunch of data and getting it from a lot of places, I like to look at it in here, because it allows me to quickly just kind of preview my data and inventory everything. There's my parcels. There's my watershed. So I can really quickly and easily run through this thing and look at these layers by previewing them over here. Now, A shapefile is made up of at least 3 files really on your hard drive. So here's this shapefiles folder that I'm looking at right here. If I go inside this shapefiles folder, remember that our File Explorer, our operating system, is not going to recognize all these formats in the same way that ArcCatalog does. That aerial grid shapefile is actually made up of all of those files. Okay? So when we talk about shapefiles, if you go to File Explorer and you think I'm talking about just that file, the 1.shp, we're talking about all the files that make up this shapefile. Okay? A shapefile does have one file that's got a .shp, but you can't use this shapefile without these files. Okay? Now technically, when you create a shapefile, it's required to have 3 files. The SHX, the DBF, and the SHP. The SHP stores the geometry, the coordinates. The DBF stores the attributes. It's the table. And the SHX ties the two together. That one-to-one relationship, which this polygon right there, which attribute record describes it, that SHX ties the two together. As you do things to the shapefile inside of ArcMap, other files get built. Indexes, projection files, other things get built. Just at the base, if I right-click right here, and I make a new shapefile, watch what's going to happen over here. I'm going to call this a class demo so that it pops up at the top, AA. You got to tell it whether there's a point line or a polygon. You could give it a coordinate system. See that? My new shapefile there. Look at these files that got built. Oh, see, it does some other things too. The one with the long name is a lock file to stop it from anything else from happening. I'll have to look up the CPG. We could delete it and the shapefile would still work. The 3 that you gotta have are the shape, the DBF, and the SHX. If for some reason you want to copy a shapefile using your File Explorer, grab them all just to be sure. Alright? It's going to rebuild some of these things when you start using it, but if you just grab the SHP, it's not going to work. You got to have the SHP, the DBF, and the SHX. So it's not a huge deal. You can copy all those as long as you know to copy them all. But when you download a shapefile from a website, it's going to come down as a zip file. And when you unzip it, you're going to have all these files. Okay, so keep up with all those things. It's best just to use ArcCatalog to manage them. Now, back to the zip file thing. By default, it doesn't show zip files. It doesn't show Word documents. ArcCatalog. ArcCatalog is used to manage GIS data. You're not going to see Word documents, zip files, PDF files. It doesn't show those things. It's just, that's not its purpose. All right? So that's a little bit different than your File Explorer on your computer. Your File Explorer shows every file in that folder, even if it doesn't understand what to do with it. That SPX, if I double click it, it's going to say, I don't know what to do with that. Okay? So, ArcCatalog doesn't show every file. You can have it show those files by going to the Customize dropdown and going to your ArcCatalog options. And you can tell it to do some things like show zip files. You can add a new type. If I wanted to show .docx's, I could have it show them. I don't care if ArcCatalog shows Word documents or not. I do like ArcCatalog to show zip files because a lot of the data I download are zip files. And so students will download a zip file and then they'll cruise over here in ArcCatalog and they won't see the zip file because ArcCatalog doesn't show zip files. But you will see the zip file over here in the File Explorer. Now, unzipping zip files, that's really kind of an operating system function. Okay, so you download a zip file from a website. You need to use the data in that zip file in your GIS, but the zip file itself isn't GIS data. It might contain GIS data. So unzipping files is really something we do with the operating system usually. Now, if you have shown zip files and you double click it and you've got a program associated with zip files, it'll open to unzip it even from our catalog. But a lot of people don't even download a zip utility anymore because your file explorer unzips files now. You probably all remember WinZip. Remember when you had to have WinZip to unzip a file? Your operating system unzips zip files now natively without any other program. The labs in here have 7-zip loaded. So when you double click a zip file, it opens it in 7-zip. There's some instructors here that really like using 7-zip. I kind of like just using the operating system unzipping utility personally. But so another thing about Arc Catalog I want to make you aware of, it doesn't update very easily. If you were to download a zip file and well, let me just do that right here. Watch this. I'm going to unzip this watershed zip file. I'm going to extract it. I'm going to put it in a folder inside of my shape files. Let's see, it's going to try to do that. No, I'm going to just delete this watersheds first. Okay, so I just deleted that. So I'm going to extract this to my shape files folder, this watersheds shape file, and watch it update. Alright, so I just extracted it. Do you see it in Arc Catalog? Where is it? Arc Catalog doesn't update as quickly as I wish it would. So if you think you did something and there should be a file there and it's not, you want to select the folder that it's in and you can right click it and refresh, or you can click the refresh button somewhere up here. You can view refresh, or you can press F5. Arc Catalog doesn't update real quickly when it gets a new file put in a folder. Be ready to refresh it if you don't see something. Alright. Okay, zip files. So we see a lot of zip files. Get used to unzipping them and managing them, using them. Most people are reasonably familiar with shapefiles. Okay, ArcGIS Online. I mentioned these state resources for GIS data. NC1 Map, Open Data Asheville, Buncombe County GIS. You can also get data from ArcGIS Online. ArcGIS Online is an Esri online mapping system. And you all joined ArcGIS Online on the first day of class. When you go to ArcGIS Online, you can search and find data in a variety of formats. Some people have shapefiles up there. Some people have geodatabases up there. A lot of times from an online service, we use either a feature service or a map service. So the data, the GIS data, lives on their server and it streams into your map, ArcMap or ArcGIS Pro or whatever your client is, from a server. It streams in as a layer. It doesn't exist locally on your computer. A lot of these services, the map services, will be raster by the time it ends up in your software. So you can't access the attributes and change the symbology and things like that. A feature service is essentially streaming point signs and polygons over to your GIS client on your desktop. Map services cannot be edited, and oftentimes you can't even change the symbology. So let's just look at some of these, and we'll just go to ArcMap to do this. Then we're going to look at a few other data sources. So I'm going to just open a blank empty map. Alright, here it is. When you go to add data to ArcGIS, if it's local, I could just drag it over from our catalog over here. I could drag this shapefile over into ArcMap. But you also have options to add data here. That's the same thing as just dragging it over from Arc Catalog. I could add a base map. Base maps are a nice, easy way to get started. And these come from ArcGIS Online. Okay, so you can get in a street map to get started. And maybe this is your base data and you just overlay your analysis layer on top of this. Maybe you want to make a map showing the bicycle lanes in the city of Asheville. And so you just use this map to zoom into the city of Asheville, and then you overlay your own bike lanes on top of it. The problem with this is that you're kind of relying on this data. How up to date is this streets data? Probably not as good as Buncombe County's streets data. But it's nice because you've got streams and roads and you've got all kinds of stuff already in here for you. But if you look at something like, say, our campus here, I mean, it's great to have a base map like this, but our building isn't on this map. It's right there. You know, our building's right here. This building is not there anymore. It's been torn down. So these base maps are a great way to get up and running. But when you start mapping a kind of a hyper-local kind of small area, you know, you kind of got to start building out your own base map if you want it to be really accurate. So these base maps streamed across the internet from ArcGIS Online as a map service. It's a service. It's not stored locally. In addition to these, you can search ArcGIS Online. Add data from ArcGIS Online. Let's see. Let's look for trails. Parks and trails. Registered trails. So ArcGIS Online, there is a ton of information up there. And when anyone can publish data up to ArcGIS Online. You all have the ability to as part of our organization. So when you publish data up online, you want to be really specific about giving it good descriptive summaries and tags and titles, because when you search ArcGIS Online, you find a whole lot of stuff that's not necessarily very useful. For instance, let's see, what was I looking for? I was looking for North Carolina roads. All right, and you'll see all kinds of stuff. And this person, the GURB, works at Polk County. Okay, I just happen to know him. He took my classes. So David put up a streets layer that comes up when I search North Carolina roads, when I'm really looking for all of North Carolina roads. So you got to filter through a lot of information in ArcGIS Online. It's a great tool and really, really useful. But you have to realize that it can be hard to dig through all that stuff. When you want to search based on keywords, and then you want to look for authoritative authors of data. You want to look for something that says, you know, ncdot.gov. That would be a good place to get the data, rather than the GURB. Maybe. I know the GURB, so I know he's actually a GIS specialist down at Polk County and knows what he's doing. So, but you'll see you can all publish data up there this semester. And so there's a lot of data up there that was done just as a demo, as a sample, as a learning activity, and things like that. So ArcGIS Online's awesome, but there can be a lot to filter through. That being said, it integrates with ArcMap. It makes it easy to publish your data from ArcMap to ArcGIS Online. There's a stack of software that's built together. So we'll definitely see a lot of ArcGIS Online. All right. Layer and map packages. I mentioned this, and I'll go into a little bit deeper here. When you work with data, let's see if I can find a good example here. The data stored in your data format, like your shapefiles, for instance. Here, Asheville, City of Asheville, primary roads. This is a geodatabase feature class of the primary roads around Asheville. Okay? Symbology is not stored with the data format. Just the point signs and polygons and the attributes are stored. When you do something like symbolize this to make it make more sense, like go into the properties of this layer in the symbology tab, in categories, I could, and I know this data, so I know that route type text 1, let's just look at it. if I hold down the control key and double click it, the table opens. I can also right click it and open the attribute table. Route type text 1 shows whether each line in this layer is an interstate, a North Carolina highway, or a U.S. highway. Federal interstate, federal highway, state highway. So I could symbolize by route type text 1. What does route type text 1 mean? Anybody know? Yeah, me either. This isn't my data. So we see that a lot. You get data from somewhere. If you download this from NCDOT, you open it, you have to kind of inventory it and learn about the data, what you can. You can look at the metadata. That makes a lot of sense to whoever made this data, I feel sure. To me, I'm not sure what that means. I know what data is stored in it, and that's what's important. So I'm going to symbolize it by that field categorically. It's not a number. We'd use quantities if it was number. Route type text 1, add all the values, interstates. I think U.S. highways are kind of second in the hierarchy usually. So I'm going to make interstates a red line. I'm actually just going to do a highway ramp because of the scale I'm mapping at. It's not really a highway ramp. U.S., let's do a major road at 1.5. North Carolina, let's make it gray, 1.2. So you can build this hierarchy of symbology there. Starts to make it a lot easier to interpret this information, right? 26 coming from the south and going out the north, 40 going off to the west and the east, 240 wrapping around Asheville, right? So it makes the data a lot easier to interpret it when you symbolize it by an attribute. So this symbology is stored in ArcMap. If you want to give someone this layer, this shapefile, well, it's a geodatabase feature class, right? With the symbology, you can right-click it and save a layer file. Now, a layer file is not the same thing as that generic layer term we've been using. Layers are everything we overlay in ArcGIS. A layer file is a specific .lyr file. The extension is .lyr, and it is an Esri mechanism to store symbology and labels that goes with a shapefile or geodatabase feature class. So a lot of times when you get data from someone, there'll be an LYR file there with it too. And if you load the LYR file, it points to the shapefile and it symbolizes it appropriately. So if you want to share some data with someone and you want them to symbolize it the way you want it symbolized, send them the LYR file and the data as a layer package. They unload it, and if they load the layer file, it symbolizes it. All right. A good example of people that do this are like zoning departments. If you get a zoning layer from someone to make a map showing zoning, they don't want you to show commercial as green. They show commercial as shades of red. And they want all zoning maps to show it the same way they do. It's a way to make the symbology consistent across maps. Layer files. Now, layer files are a layer file and they store symbology for one layer. How about a whole map document? Map documents just reference GIS data. Okay, so let's look at this. All right, I don't like that county boundary. I want it to be no color, and I want it to have a different kind of outline. There we go. All right, so how about this map? Okay. This map document has not been saved. I'm going to save it real quick. And I'm just going to put it on my desktop and call it demo. All right, so does everybody see what got saved here? Demo.mxd. If I wanted to share this map with someone, the whole map, giving them that demo.mxd would not, if they opened it, they wouldn't have the data. The data are stored. You can look in the table of contents and list it by the source of the data. That data is sitting on the server here in a geodatabase. So if you share that map document by emailing it to someone, or for an assignment, you upload a map document to me ever, I'm not going to be able to see the data in it. I'll probably likely have the data because it's an assignment, and I could repoint it to the data, but you can't just share a map document. They have to have the data. And so what a map package does is it takes all the layers in a map, all the symbology and the map, and puts it in a package. When you send it to someone, they can double click it and it opens it up and puts it on their system in a way that they can just open it. So it allows you to share maps and layers. All right, map packages and layer packages. Those are Esri-centric things. Okay, a few data considerations, and then we'll come back to a little bit more demo. This is going a little long. What's the format? Is the format something you can view and look at? What is the spatial reference? That is going to be the topic for week after next. What coordinates are with it? That's really important. And I will emphasize that over and over again. Your data needs to have the coordinates properly defined in order for it to overlay. Where's the data come from? What's the source? Is it an authoritative source, or is it off of somebody's app on their phone for the hike they went on last weekend? That's a pretty good data source too, really, in all. But look at metadata. Does it have metadata that describes anything about the information? Metadata describes how current it is, what attributes it has. Attributes. Are the attributes there useful to you or not? I'm working on a map right now around Hot Springs, North Carolina. I got a bunch of trails data. I really want to symbolize those trails on their use, whether you can only hike on them, whether you can also ride a bike on them, or whether you can also ride a horse. In the national forest around here, we have hiking trails, hike-bike trails, and hike-bike-horse trails. The data that I downloaded for up there doesn't have the use of the trail. I can symbolize them all black or any color I want, but I'm going to have to add an attribute and update every one of them myself. And so that happens. How current is the data? Is the data, has it been updated recently? There's a couple new trails up there. Is that in that trails data set? Was the data built for mapping a small area like Hot Springs, or was it built for a nationwide scale? If you look at some data sources, scale's an important thing. Let's look at a data source here real quick. Here's some data built for the United States of America. And here is what the state's boundary looks like in this layer. It was built for a small scale, large area, but if we zoom into something like the Outer Banks of North Carolina, is that a really good representation of what the Outer Banks of North Carolina looks like? That data is really good if you're mapping the entire country. If you're mapping the Outer Banks of North Carolina, that data was not built at a scale for that. It's too generalized. The data's generalized. And a lot depends on the scale you're mapping at, the source, where it came from, that kind of thing. All right. Are there use constraints? Are there licensing constraints to using the data? Consider that. All right, so preparing and using data, make sure the data format is supported, perform conversions, modify the data. If you need to create a slope or a shaded relief model from elevation data, or if you need to add trail use to a trails layer you might need to clip down data sets or merge data sets together. I'm working in Hot Springs. It's on the border of Tennessee and North Carolina, right? So NC1 map's got a lot of great data, but if I get roads from NC1 map, I'm going to have to get roads from a different data source for Tennessee, and I'm going to have to put those together. Okay, so you got to think about if you've got to combine data sets or clip data sets down. If you're working in the Smokies is in North Carolina and Tennessee. So a lot of times when you're working there, you have to put data sets together and then clip them down to that boundary. So a lot of processing of data. We might have to create points from tabular coordinate data. These are some considerations. We've talked about some of these things, so I'll let you read over these. And I did want to just make a quick mention of some other data formats. Data formats that we haven't mentioned. We've been talking about the Esri world of data formats. I did mention Google Earth. Google Earth uses KML or KMZ. KML is a markup language. keyhole markup language. Google Earth used to be called Keyhole. It was a piece of software that Google bought, and it was named Keyhole from the first spy satellite program was codenamed Keyhole. Our United States spy satellite program was called Keyhole back in the 60s, 70s, and so they named this program Keyhole. Google Earth bought it, rebranded it Google Earth, but they still have the old KML format is what they use. You can't add a KML file into ArcMap. You have to convert it to a shapefile or a geodatabase feature class. GPX is an open data exchange format for GPS data. Your phones, the apps on your phones, any one of those apps you can download as KML and GPX really easily. And then we have to convert it to get it into ArcGIS. GeoJSON is another similar format, and you can see a lot of those on this Wikipedia page. If we can go just for another 5 minutes, I'm going to do a little demo here of some data sources, and then we'll take a break. So I just did a quick search on GPS and Bent Creek, right? And it came up with this website. Have you ever seen Hike WNC, Jordan Mitchell's website? This guy's got a great website for hiking and biking around the area, and his website's got all these great descriptions and pictures of places to go and a map. And if you click on a trail, you can download it in KML, GPX, or GeoJSON. So I can get data right from here. So if I was making a map of Bent Creek and I needed some trails data to put in ArcMap, I could download it from here, convert it to an Esri format that ArcMap can read, and look at it. So to convert it, that's a good question. In ArcToolbox is a bunch of tools for converting and working with your data. There's a tool for converting KML to a geodatabase, and there's also a GPX tool. I don't think either of them work really well. You can still write it down because you might want to see them. ArcToolbox. ArcToolbox. Uh-huh. Let me show it to you here. Here's where ArcToolbox is. It's right there. Okay? Bunch of tools for working with your GIS data. There they are. Whole ton of them. This is one of the places you'll see some differences in your license levels. In ArcMap, a higher license level has a lot more tools in here to work with your data. Now, here's a bunch of conversion tools from KML, from GPX, okay? JSON 2. To KML. Export your data to KML. Okay, so a lot of tools here, and you can search for them as well, which is a little bit easier. There's a search tool too. You can search for these tools. Now, personally, I use a program called DNR GPS that you'll see in another. It's a free open source program from Minnesota Department of Natural Resources. You used it? Okay, for DNR. So Department of Natural Resources built this program to interface with their GPS units, and it converts between formats really easily. I like to use it. It's better in a lot of ways. Another program that does it really well is QGIS, Quantum GIS. That's not loaded on this software. QGIS looks a lot like ArcMap and has a lot of the same functionality, except for it's free and open source. The thing about QGIS, though, when you click the Add Data button to go to Add Data in, the list of formats that you can add in there, there's like it reads every format. You can load anything you want in there because it's an open source program that its whole purpose, it's not whole purpose. The open source movement is all about interoperability across systems. ArcMap and ArcGIS and Esri, they say that they're committed to open data standards, but they make it a little harder to use other data formats. All right, they make you, it's a little bit hard. They want you using their data formats. And honestly, if you're in ArcMap working, their data formats work the best. So, you know, but it's nice when you're in QGIS, you can add whatever you want. You can right click it and save it to any other format. It's really easy to convert between formats in QGIS and DNR GPS. You have to know the URL and put it in. Yep. And I can demo that as well. All right, so a couple other sites I wanted to show you. Let's see. Okay, so that's that GPS map. I like to do the Google search for Linville Gorge has got a ton of GPX and KML files. There's a group of people who go in there and they've got these great maps and data for Linville Gorge. Linville Gorge is a wilderness area going northeast from here, and so if you so this is a KML file. If I click it, because a KML file is a human readable kind of text file, really, well, sometimes it'll just open in the browser, but see it downloaded, linville.kmz. If I click that, it's just going to automatically open it up in Google Earth. Has anybody ever been to Linville Gorge? If you haven't, I recommend going. I recommend taking a map, having some map skills. It's a pretty rugged area, but this is Linville Gorge, and they've got all kinds of data for it. So we could convert this data. I've got Linville Gorge on a map that I made, and their data is specifically, this data set right here is not to be used for commercial use. If you look at the license model for the licensing agreement for it, and it's just it's the, what do they call it? The gorge rats, I think they call themselves, the guys who build and maintain this data. But it says don't use it, and I contacted them, and they actually let me use some of it for a map I made that I sell. So, you know, you got to look at and try to respect people's licensing models. So, but there's KML, KMZ. It's good data. It's interesting data because a shapefile, you can't just open up and look at it. KML, if I right-click this thing and I tell it to open with a text editor, well, that didn't work. Huh. Oh, that's the KM. That's because it says Z. The Z is compressed, so you can't read it. If it was in KML, you'd see the coordinates and descriptions, and you could just read the file. Same with GPX. I could go back to Jordan's page and probably grab a GPX file that we could look at. I'll get one of these from here. So, all right. So here's my Strava. Does anybody know Strava? Right? Strava's an app on your phone that you can track your runs, walks, hikes, whatever, bike rides, and I use it to keep up with exercise. But also, this is our campus trail that I'm involved in mapping with our committee that's working on it, and I can export that run right there to a GPX file, and you can see this is what a GPX file looks like. And if you open it with a program that will recognize the tags, you can actually see the coordinates, the descriptions, and things like that. It's a human readable kind of thing. But I can convert this to I could also convert this to a shape file and look at it in ArcMap. I can't look at it outside of I can't look at it in ArcMap without converting it. GPX and KML are formats that are built to work on the web. They work really good on the web. Our shapefiles work in the Esri-centric world better. I can get that data right off my phone. This is just using my phone to collect data, and I will end up making a map. I'm going to update. I'll show you the map I'm updating here real soon with this. All right, so this map right here, you see this little trail on it right here? that I'm updating with this GPX data. So right now I've got it starting here and going around to here. I need to add this chunk onto it right here. I'm not adding this part. That's where I'll run from our building to get over there. But this chunk right here where it cuts up around this way needs to be added to this map. And so literally I went out there with my phone. It's going to come around here. It's going to cross here. It comes along these and it goes back into here. It makes a loop. Okay, so I went out there with my phone and Strava to collect data to update this map. All right. Strava's pretty neat because you can look at their global heat map. This is where everybody goes using Strava. They've got all this data, and it's pretty wild. They are sharing this data with city planners. There's Asheville. They're sharing this data with city planners to show where people commute, hike, bike. Most city planners for where people commute. When you use Strava, you can click a button that says if you're commuting. And so they can better plan cities by how people are using cities. Now, this is like the old sitting there and counting cars going by, writing it down, right? So this data is pretty useful for that kind of thing. Yeah, pretty neat. What else was I going to show you? I like showing Strava. There's lots of places to get data. If I'm looking at some Forest Service data and I'm mapping a trail and I'm not so sure that trail looks right, I'll go to Map My Run or Map My Hike, one of these apps you can put on your phone that people record their hikes and their runs, or I go to Strava and I look to see if I can look at other people's segments and compare it to the data that's on that I got from the Forest Service. And if nothing else, I might realize that I need to go out there and actually look at it myself. So, all right, so that's kind of a rundown of data. We will talk and look at data a lot more this semester. Thanks for letting me record it this time.